Cool. All right. So let's get started. Welcome everyone to the very last chapter of designing machine learning systems, and it's the human side of machine learning. So we'll talk about our presenters real quick. I'll introduce myself. My name is Anirudh Dharmarajan. I'm an independent consulting, helping small businesses apply AI for their operations. And I'll be timekeeper today. So if you hear me chime in and say like, "Hey, timekeeper here, we got to move on," so please move the discussion over to Discord. I don't. It's not personal. We just got to keep everything moving. So you'll hear me pop in from time to time as we have a pretty discussion-heavy presentation.
Yeah, so this is Atif Salim. I'm senior security consultant at Nokia. So I'll be looking at the responsible AI side of the presentation today. Thank you.
I'm Philip Hartman. I work as a machine learning engineer, Hartman Queen. I work as a machine learning engineer, and I'm working mostly on natural language processing projects. Yeah, we can get started. So uh, the first thing we want to talk about is comparing traditional software versus machine learning machine learning systems. And so the biggest change is that with any input in traditional software, you know what the output's going to be. It's going to be the same every time. Whenever you put that input in, you're going to get the same output. And the people developing that software can predict what it will be for unseen data. They wrote the algorithm, they wrote the heuristics, the program. Whatever they get, they can predict what's going to be output every time. Where we transition to machine learning systems, they usually leverage probabilistic models that don't output a single output for the same input. They will actually, depending on the system, output a range of outputs and the probability for each one. And then if you apply a sampling approach to that, which LLMs are a great example of this, you then are potentially getting a different output for the same input each time you pass it through the model. And on top of that, when they're exposed to unseen data, since it's not a program they wrote themselves, it's not always you're not always able to predict exactly what it's going to output for that unseen data. Everyone works to do their best, of course, validating these models and getting them exposed to the largest amount of data they can, but you're never 100% certain that you know every single output that's possible for a given input. Um, so yeah, when you sample, you can get a different output each time, and that actually is basically amplified through LLMs, where each token is itself an output. So the next slide will show you might put input through once and get output two. You might put that same input through, or prompt your LLM again, same thing, same prompt, and get output three. And then next slide. And then this is, again, amplified by the fact that output three itself is not the final answer. Output three is then actually a token that's refed into the model. So next slide, we can see this, goes back in, is basically appended to the input. And then next slide helps to determine what the next token is going to be. So this means that when you're changing, you're not going to get just, oh, did I get output two or output three this time? You actually might be getting output three, which leads to a different output five, which leads to a different output 10, et cetera. And this just kind of builds on itself and can result in wildly different vocabularies of responses or generations. But ideally, the model is still accurate. And so if you have a prompt that generally requires like one main sentiment answer or message value, could you back? Yeah, sorry. Then even though the vocabulary changes significantly in the messages of the generations, it doesn't necessarily change like the value of it. Saying the same thing with different words is the goal for a lot of these LLMs. Now, since we're dealing with probabilistic models, even since we can't predict everything, there's still a chance we can draw heuristics that are saying, hey, this output should be optional. It should be a logic we allow as an output for a lot of generations, but maybe there's still heuristics we can add to say, hey, that's an invalid one. Like even though there are times when we would want to output that, there are also clear times when we know for a fact we should not output that, or where we know it'd be risky to. And so think about it like configurations on an instrument. You don't want, there's certain ones where hey, if I have this as an input, that output is either risky or just it's going to be an issue. And so you can kind of merge the two where you have heuristics that are guiding your output. This is guiding generation to avoid those invalid outputs. So let's say that output 5, for example, is invalid. Then yeah, next slide. We can kind of just mask. Outlines does this by actually masking the logits. And so Outlines is a great tool that literally you can pass in a regex pattern. It creates a state machine based on it, and then will mask over whatever tokens do not match that regex. So for example, outputting JSON is a really easy case where you're actually not going to be affecting the accuracy at all because JSON is very structured. You can guide the output so you know that you always get an ending curly brace for when you have a beginning curly brace. But so you're not actually sacrificing accuracy, you're just guiding it in sometimes what the outputs should be. And this kind of moves on to the next part that Chip talked about where we talk about trade-offs. So next slide. Yeah. Next slide again. Yeah, so here we can see what's actually going on. If you have the regex of a number and then a decimal, or as many numbers as you want in a row, and then a decimal and another number, and our tokens or vocabulary in this case is just a decimal, dot 2, and 1, we can see the first one, the only valid option is the number 1 in our token. So we take that and move on to the next one. But in the next part, we can see we have 3 valid options and 1 invalid option. And so this is where the sampling comes in, where we do still want to have probabilistic sampling there over those valid tokens. We just want to block out that top one because we should never see 1A in this case. And so since Outlines does this with just masking logits, it's not actually a significant slowdown in latency, but it's also a pretty heavy-handed guidance. So it's kind of all or nothing. That logit is or isn't included, which depending on what you're guiding it for, can hurt accuracy. There's times where, like, again, let's go back to instrument configuration. You might have a more optimal configuration that might sometimes be risky. And might again, if you set certain things too high, you could damage your equipment you're working with. And so even though it might be optimal in some cases, this would be the trade-off of it's less accurate because here we are just saying, no, you're not allowed to output this option. And that starts to lead in that trade-off of accuracy and consistency she talks about in the book. Again, at this point, speed isn't really an issue, but that'll come into play in the next ones. I'd like to stop for a second here and bring up a discussion question. So I talked about Outlines here, and I'm wondering if anyone's used Outlines or other guided generation tools, things like guardrails for LLMs and other generative AI. I'm not sure if Andre is on, but I think Llama Index has done some work with this.
Yeah, I think it's pretty useful.
Yeah, guardrails is also pretty useful.
Cool. I mean, do you want to talk at all about like what it is you did with guardrails, what you were preventing from being generated or anything?
Oh, I mean, at a high level, just to make sure I don't spill too many details, it's mostly just about preventing certain topics from being discussed or being sent back to the user. It could also, it's also pretty good, I think, for providing like a boundary to make sure you're providing like ethical, useful information to the user. So you could definitely customize what kinds of topics you're preventing and what you're basically like almost like an allow list.
Yeah. Awesome. Yeah, I think that it's pretty cool for stuff like that. And yeah, it can do pretty good job at avoiding certain topics again or certain tokens, whatever it is you're guiding. It's awesome stuff. So, all right. I guess we can continue to the next part. So another topic in the book.
I think I was gonna add on the structure output. I think that using a tool is only just one of the many solutions. So yeah, so I think just like as models get better at following instructions, then many of them will just be able to like output expected JSON or YAML or regex by default. And I think people also try to use fine-tune on like specifically formatted data, and fine-tune has proven to be working quite well for expected formats.
Yeah, definitely. I completely agree. That is just definitely can be a bit more work. Outlines, you can just write your regex and go with any model. But if you have the resources, fine tuning for your structured output, I think, one issue with outlines I've noticed is when you prompt for something, but then you force a certain output. So for example, if you don't say, hey, I want JSON, you just force outlines to mask logits to give you JSON, the LLM will actually output less accurate answers because you're guiding it in a weird way. So if you can fine tune it so it, quote unquote, knows what to expect, it will definitely get better results. It's just, more resource heavy.
And that's where maybe control vectors might be really helpful in the future, where we can say like, inject a control vector for a certain type of structured output or like a tone or things like that. So it could be a really cool, application, maybe combining the ability to use outlines-based output masking and a control vector guidance.
It's pretty cool when you merge, basically like prompt engineering and fine tuning, so you can get things like system prompts, control vector, a lot of this stuff. So the next topic, is human in the loop. And so another way to drastically improve like the guidance of things, making sure you're getting only improving validity as well as accuracy, is adding a human judge. We generally think of humans as like the top quality. Generally, LLMs are trying to compete with or mimic humans. We're trying to get them to be as good as humans. So adding one in the loop will allow it to kind of filter that and make sure you're filtering for whatever you want. And humans use nuance when they're looking at things. They can catch things that are wrong, and it's just great for both validity and accuracy. Of course, there is the very large negatives of cost and latency. So now again, we're entering that trade-off and the speed trade-off here. So adding a human in the loop will usually significantly slow systems down. LLMs generally generate a lot faster than humans do, and also they're generally a lot cheaper. But you just can't beat the accuracy, especially if you have someone who's a subject matter expert. You just get such large gains there. And so, but the cost and latency are significant problems. So companies are trying to solve that. And one way is to actually kind of find an in-between place where you have an agent in the system. So next slide, this is where you're not just using a LLM, a single LLM, but you might have a secondary LLM that's been fine-tuned for a specific purpose or use case. You might have a small LLM that's running most of your inference because it's cheap and able to be run, but then you might have a large LLM you run after you send certain outputs to for just using it less for cost reasons, maybe even speed reasons, but it can improve the accuracy and validity so much that it's kind of worth going to and still faster than a human, even though it still won't be as nuanced or as positive improvements on that accuracy as a human would be. But like we can see Apple doing this. So Apple has, now they have their hierarchy of like on device followed by private compute followed by GPT-4, where they're kind of choosing which one should go where. And I imagine that cost is a large part of that, as well as also, latency and accuracy. They're kind of looking at all those trade-offs together and deciding when each input should go where. And so now I wanted to pause and talk about this as well, kind of open discussion up for what other people see with multi-agent systems. I think we saw last week someone set up one that was taking advantage of this, kind of having different agents for different things. And I don't remember if it was hierarchical or it was like a large model and a small model. I think it was more based on fine-tuned for different use cases. And we've talked also before in this group about Prometheus, where it's a little bit different, but for judging LLMs, it was kind of like doing the choice between which output was better. And that was, I think, still an open source. I think it was 7-bill model, which is pretty amazing. You can have such positive results from fine-tuned 7-bill models instead of going to GPT-4 for everything. Does anyone want to talk about their use of the multiple agents?
Like multi-agent is already used a lot even though people might not think of it as like multi-agent. First of all, like self-critic. Like if you use a model to like act, another model to critic, is like two agents interacting with each other. Or like if one is planned to do the planning and the other carries the action execution, is that also multi-agent?
Yeah. Yeah, the planning execution is another one. And then, yeah, I was generally thinking about it in this case as like being that filter, but there's, yeah, tons of use cases for multi-agent systems and even, yeah, using it back to like reprompting the same model. Yeah.
Yeah, like routing can be an agent. Scoring can be an agent. And what I talk about, I think, is do you mean by the reward model? It's in like looking at input and trying to give a score or like comparative evaluation?
Yeah, I believe
Which is
Prometheus did
better.
that.
Yeah.
Yeah, I believe Prometheus was taking two inputs and deciding which one was better, if I remember correctly, and that was allowing it to basically decide. I think they were doing fine. I think people generally were doing fine tuning on top of the outputs from Prometheus, so it was kind of a synthetic data generation tool. And that's, yeah, I guess that's another place where we're looking at agents. It's a little bit separate because it's not at inference time from this. So it's not like necessarily user experience at inference, but synthetic data generation is replacing humans with agents instead of labelers or just generating question and answer pairs from documents. There's a lot of different things people have seen. I think AI Makerspace did a whole tutorial going through how you can use GPT to generate question answer pairs. So that's your agent instead of a human to then train llama on. So yeah, pretty common approach. And again, just the trade-offs of gaining such a large amount of accuracy and validity without sacrificing too much speed compared to adding a human in the system and cost.
Yeah. I think there are other papers like Panda LM, Judge LM. I think there's just a lot of value in being able to predict human preference.
Yeah, 100%. And there's also, I remember actually polls. So now we're talking about multiple agents. There's a paper called Poll, I think, that was focused on having like 5 LLMs take a poll on as judges on the output of another one. So I think we also kind of enter the realm of like, all right, are we kind of overdoing it? You can't just throw every single, more LLMs don't necessarily mean better results. Maybe one good LLM as a judge is better than having 5. But I think they showed a few different insights. I think sometimes it is beneficial.
This is a whole school of studying on ensembling, like having different models, but it only works if these models are like not strongly correlated. Because if you're having 5 models of two things exactly the same, then it's not going to be very useful.
Yeah, exactly. If they've all been trained on the same data, if they're all trying to do the same thing, it's like, well, why are we using 5? They're all averaging out to the same. Cool. So we can continue. This is the last slide on user experience. So I think I'm trying to remember we just said this about the agent prediction, but what some people do for the latency issue is they're trying to figure out, hey, I have this really great model, but maybe sometimes it's slow, and maybe sometimes certain inputs don't require that large one. And so rather than sending all your inputs to the same large model that's expensive or slow, again, that hierarchical approach, you can put in smaller models to handle certain queries and then deciding where they go. I think Chip just mentioned using an agent as a router. That's kind of what this is, where you have you can take an input and then pass it first to a response time predictor, which will tell you how long the big model is going to take. And if it's fast enough, then you can send it off to the large model and let it go. And if not, if it's too slow, then you might have a less accurate, even heuristic-based approach to answer the question that would run instead. And again, this is kind of trading off accuracy, but keeping time and count. You don't ever want to have it, having users wait too long makes them not want to use your system, even if it is accurate. So there's that. And then the funny part of this is in the book, she talks about how basically the response time predictor added to, as a serial approach where the input first goes through that model and then the next models can actually have a negative impact on latency because it's just taking long. It's just adding a step to the process, which is kind of ironic since it's there to try and minimize latency. Yeah. we can go on to team structure. So this is the quote from the book: what one programmer can do in 1 month, two programmers can do in 2 months. And I just think this is an awesome and hilarious way of reminding people the costs and difficulties that come with adding team members. Complex tasks are usually done better with a lot more people than just one, but it has to be the right people, and it's also tangent or dependent on the onboarding costs, the fact that you need to get a team dynamic set up, you need leadership organizing things and the way it works. It's not just throwing more people at a problem. It takes a lot more planning than just that. So yeah, we can continue. I like to think of it kind of like how computer systems have evolved over time too. So like we used to have one CPU and we would feed it, small programs. It would handle the small programs, and that was it. Small tasks are done well by a single CPU on a single thread, and we're good to go. We can continue on, and CPUs got bigger. They started handling much larger tasks, much more complex programs, and they just had to be a lot faster and better to be able to handle all that. And so that's what they did. They just made them larger and made them faster, and we were good to go. But this eventually was overtaken by multiple CPUs. And this is where really the team dynamic, of course, comes in, because we're doing multiple cores. So now we have multi-core CPUs that beat out one single core CPU that might be much faster. That first CPU might be faster than any one of those cores, but having 4 moderate-sized cores, just even though it requires a lot more effort to use them, just completely beats it. That's why everyone's switched to this approach now. And you can kind of think of that with the data scientist being the end-to-end data scientist who, they might have learned a bunch of skills like Kubernetes and Airflow to be able to handle this large, complex project. But if you had a team where one person knew Kubernetes and Airflow, and one person was a subject matter expert on the data, and another person had a lot of experience in machine learning, that team will probably pretty confidently outperform the one person who's decent in all things. We're talking about the jack of all trades versus 3 masters of each, each of one, or one of each. Yeah, sorry. But that also, again, isn't free. You don't just put those 3 people in a room and say, go. You also need to plan it. When you're writing code for a multi-threaded program, it's not as easy as just writing a serial program. You need to handle threads yourself. You need to plan for it and write it in a specific way to take advantage of the parallel processing parts. And the same way that a team needs a good leader to kind of plan out the project and make sure they're hiring the right people. If you hire 4 people, but none of them know Kubernetes, then you're not going to gain any benefits versus the one guy who did know Kubernetes as well. So, and then beyond that, we also, now computers add GPUs in too. So now we're expanding even further, again, bringing more subject matter experts in. And the idea is we're really using a lot of different skills, and at the same time, adding costs. The more people you have, the more different skills you're working with, the more communication has to happen, and the more difficult the communication is to happen. And this is kind of this analogy still plays here, where you have a long time when you send programs to and from, or information to and from this GPU and the CPU. That can be your bottleneck. If you're running a whole program on a GPU and you've programmed it that way, then you're good to go. But if you're passing information back and forth constantly, it can be pretty slow, unless you're on an Apple, I think. And then, well, now the analogy kind of breaks down. So what's the solution to this? We can talk about how people are trying to solve this specialization problem, where you can bring people a bit more end-to-end access without the high costs of it. And so that's where the next slide talks about different tools and abstractions. So there's like data version control and data systems like LakeFS and DVC. But then there's Pachyderm, which really abstracts this whole process. And ideally, you have one person come into Pachyderm and just put the data into a pipeline that maybe a data scientist, a machine learning engineer, and maybe an MLOps person set up. And the person adding data doesn't need to know what's going on. They're just leveraging the tools and pipelines that other people who are experts in making pipelines set up. And then that goes on to other systems like there's Celadon, which is used for deployments. And then whenever someone who maybe the manager wants to check on how the project's doing and they want to see the metrics, they just open up their browser and go to something like weights and biases or MLflow, where you can get a overview of what's going on without looking too deeply into it all or running it yourself. And these tools are meant to abstract layers like, again, Docker and Kubernetes, which you kind of need because you don't want to have someone writing something on their machine that doesn't, go and work on anyone else's. You want to really make things as containerized as possible that can run wherever they need to run, and without the cost of having every single person know the ins and outs of each of these programs. So these tools are all trying to kind of abstract that and make it easier for people to be a bit more end to end and leverage things without the startup costs of learning it all. Yeah. So does anyone want to talk on their experience of working with programs like these? I'm not sure. I think Chips used weights and biases a bit, but I'm especially interested in things like Pachyderm or Airflow and Valo High. Yeah, these things that are really meant to really abstract a lot of the processes away. And if not, that's okay. A lot of these tools are also new, and I mean, I know Airflow's been around a bit, but there's just a lot of development still happening with them.
I think one tool that was really cool for the like business side of the house in a couple of places that I worked at was Hex, so that they can kind of enable business SMEs to build visualizations, build like notebooks essentially without really needing to know a lot of code, right? Like their AI tooling has come quite a ways, and the connections to all the different data warehouses allows them to access like a skill set that would have been otherwise like inaccessible.
Yeah, that's super cool. I know the notebook approach, and we talked about before how more and more people are going towards that notebook approach and getting tools that kind of build off that without needing too much technical expertise or coding knowledge. Yeah.
New category of tool would be like gateway. So to allow you to access models from different providers in the same unified manner, but can also provide guardrails, like first of all, PII reductions.
Yeah, that's actually I didn't I was trying to focus on MLOps tools, but like Olama is one, like ChatRTX I haven't used, but I know there's a lot of tools now popping up just for allowing people to use models. It's, hey, you don't need to know how to code. You don't need to worry too much about deploying these things. Just run our program and choose a model and go. And it's definitely really cool to see people getting involved in spaces that previously had a pretty high barrier to entry, and due to these tools and abstractions just is getting lower, and we're having more and more people there, which more discussion, more education, everything. Yeah.
Yeah, I'm so curious about like the role of Kubernetes in AIs going forward. I think that's like pretty good for deployment, containers approach, but also very, very heavy. Yeah, so I'm wondering, I've seen that people deploy the infrastructure like without Kubernetes as well. So I wonder just like future going forward. And I think it was a thing you mentioned about process. I think some people might call it orchestrations. So something, and there's a lot of tool like Prefect, Stir, Metaflow. I think that area is extremely exciting.
Yeah, I agree. Cool. All right, well, that concludes the topics of user experience and team structure. I'm going to hand it off to Responsible AI now. So.
Cool. So we're gonna spend the rest of the time talking about responsible AI. As Chip wrote in the book, it's a gigantic subject and could easily span multiple books. The picture on the screen right now is from an IBM presentation given in 1979, and it's still pretty relevant today. The original was unfortunately lost in a flood, but people have clearly been thinking about the implications of automated systems for a long time. And so this next section is going to cover why we should keep thinking about it as we build ML systems. We'll also look at Chip's responsible AI framework as a lens to discuss some of the examples that pop up in our industry. So why responsible AI? Why do we need it? Let's take a look at what happened in Idaho. In 2012, Idaho decided to use a black box ML process to determine how much care developmentally disabled individuals would receive through Medicaid, which is a state health insurance program for people with low incomes. As a result of that program, all of a sudden, a 53-year-old woman who has muscular dystrophy, who can't fully take care of herself, had her budget for care cut with no explanation and no way to appeal. This happened to thousands of people, and the state basically said, "We can't tell you how we do it because it's a trade secret." And they gave no underlying causes or transparency in how the model worked. Court documents over the last decade revealed that the underlying data and methodology were very flawed, but Idaho and the Department of Health and Welfare went ahead building the models anyway. And a lot of people suffered as a result. This pattern kept repeating across multiple states in the US, and it's still a struggle and an open topic on how do we regulate and how do we maintain accountability at the government level when deploying these models. In this case and many others, accountability was basically hand waved away because people were literally saying, it's not me, it's just the computer telling me that this is how much money you get for care. Strongly recommend reading the article linked here as it goes through a lot of detailed human examples of how people are affected. Another example that popped up recently on X a few days ago was from Casey Climbs, who's a senior UX designer who used to work at Google. And the quoted put a tweet, I don't know what to call it these days, that like someone mentioned and posted, Google Maps really needs a feature for the nicest way instead of the fastest way. Casey chimes in and says, this is a feasible feature. Personally, he would love this feature as well, but fought it. And I'm going to summarize the thread because I think it's a really good indicator of why we need these kinds of conversations as we build complex systems. So Maps has over 1 billion users worldwide. The main objective of the Maps algorithm is primarily the fastest route between two destinations, 2 points. When you introduce some sort of filter like the nicest way, that introduces quite a few subjective differences. Like, what does nice actually mean? Does that mean more trees along the route, like less crime, better views? The author basically said, as his previous experience as a city manager, there's a lot of research that showed lower income communities had just way fewer trees. So if you chose that as a metric, you'd suddenly start directing foot traffic routes to avoid lower income communities, and then keep reinforcing the feedback loop of not enabling revenue opportunities for those businesses in those areas. So we have to be very, very thoughtful and careful as we design and build large complex systems on how they could affect the people in the communities around them. I'm going to hand it off to Atif to talk about the responsible AI framework that Chip proposes.
So in the book, Chip, laid out the framework that lays down the foundation for ML practitioners, how to audit the model behavior, and so that you can set up the guidelines, that can have kind of a best practices and can help us. So in short, because we don't have much time, so she goes in each of these in detail, but the whole purpose is like you discover the bias sources, whether it's like whatever stage it is, like whether it is coming from the training data, or it is coming from labeling or feature engineering, or when you are doing the evaluation. So you are not, it's just to see that how the biases are coming, okay, and how the data is skewed. And then you understand the biases and what are the limitations, what are the trade-offs. For example, privacy versus accuracy. I can compare this to like in our security. So mostly we come like performance versus security. So something similar is here. So you have privacy, and then you have to focus on accuracy, because in real world, so we are focused on the project timelines. They are strict timelines. So there are trade-offs, and you need to understand them. And by understanding them, you need to act early. By acting early means like you don't ignore ethics and other kind of that can impact your responsible AI. So you don't bypass them, you don't ignore them, because at the later stage they can cost you more, right? So and then the next step is like you create model cards, right? Which comes from the paper. So the model card is like you lay down, you get all the information, like how the data was, trained, and everything about the data, like the model, like how the model was trained and what were the factors that were taken care of. So you have all that in a kind of a small document, so which can be used later on. And then based on that, your understanding and the by sources and the model cards, so then you establish the mitigation processes, like how can you mitigate those biases now and in near future, right? Or in future. So this is like in short, but at the same time, because still this field is evolving, so you need to stay up to date, right? For example, what I can think of is right now, so recent EU AI Act, so that you should know like what is being considered. Because if you look at one of them, for example, the one from AI Fairness 360 by IBM, and then the others as well, Google has also published the best practices. So you take those into account, and then you are well prepared in future that either those biases that have already happened, they don't happen. Even if they happen, you can act early and then you can mitigate them, right? Because you already have established the process. Okay, we can move to the next slide. Okay, so now okay, so looking at the process, it's not exhaustive, right? So I would like open the discussion table, like what do you think can be added to this framework? I personally think like after you create the model cards or after you establish the mitigation process, you can share with the community if it is open source, or even within the organization. If it is going out of the organization, of course, keeping in mind the privacy concerns, I think the what I can add here is like it should be shared with the community, right? So any ideas like what else can be added to this framework? Yeah, Chip,
Well,
would you like to add something?
feel like so this is not my framework, by the way. Is this on a framework that so the chapter was co-authored by another there's a scientist who specialized in responsible AI. And this is the framework that he proposed, I think is by Microsoft. So I felt like as someone who's not specialized in responsible AI, it feels pretty challenging for me to like try to add to it.
Yeah, it really is good, but you can apply to most of the models, like, but it doesn't mean like you can apply everywhere. So that's why I'm like, right now at this stage, is there anything we can add? Because at the time of the book was published, so from then till now, is there something that we can add? So for me, it was like we can share it to the community, right? Like whatever the model cards and whatever the mitigation processes we have done, so that they are well prepared for those biases, as well.
Yeah, I think it also like another new challenge that I think is like using sharing data and also like how models so it's like with search, right? Like when you search and the results are so you can see the search results and then you can link back to the original source. But then with AI responses, AI aggregates data from a lot of different sources and it produces an answer. And the people seeing the answer have no idea where this content come from. So it's just really hard. Like, so for example, like I can write a book, right? And somebody can create a bot that basically gets this book or like other books to like create a chatbot Q&A for people. And people can just consume the bot without knowing what the original author is. So like for the original author, I don't know like what could be incentive for them. to when you create content. I think the same thinking are going through in a lot of community, like especially artists, gaming community.
So it's like even if it is they are shared, they are responsibly shared and distributed. Knowledge sharing session about. Okay, so we can move to the next slide. I think Shivam is saying something in the chat. Knowledge sharing session about the AI product would help. Yeah.
Yeah.
Some,
Similar to your point too about communicating it to the community. I've seen at my organization, we discuss multiple formulations from start to end, and there are a lot of open-ended questions that you get, a lot of pointed questions, including like diving deep down into the formulation, and of course equally like important problem of designing the experiment, right? So the whole, like when there are multiple experts that are poking the whole formulation from different angles, you get a lot of inputs that you, of course, having limited view, will not have. So I feel that also contributes towards having a responsible AI culture. But it is very close to what you said, basically communicating it to the community.
yeah. The good thing about this session is like when you are sharing something, you're also learning from others, So you also know the biases which others have, countered. So you are also, then taking care of them in your organization. So that's the best thing about, when you're sharing with each other. Yeah, thank you. So we can move to the next slide. So this is also kind of a discussion, kind of how do you find these sources of bias? It's just one of the example. Like recently, there is a blog post by the Google. How you can use Google Maps, generative AI in Google Maps to find the places and things to do, activities that interest you. So when I was discussing with Anirudh, what biases can be there. So one like clearly biases can be like either the businesses, places, or local guides that don't exist on Google Maps. Maybe they are really good, but they don't exist. For example, when it comes to the restaurants, etc., maybe you can find better, kind of uh, information about them on Yelp, right? Or on, let's say, Grubhub or something. For example, there can be outdated prices, there can be outdated contact information, It has happened to me, like when I contact them, then that's not the number, actual sometimes. And even if they have the menu card, but the prices are outdated. So then you have to go and look at Grubhub or Uber Eats, etc. So this is like one of the example. Another example is like the ratings. So either there can be skewed ratings, like either they are just AI generated ratings, maybe like some businesses can do that, and that I mean these are fake. And this is one thing, one part. The other aspect is like even many people don't bother rating. Even if they do, they don't do it honestly. They just, I mean, not all of them, like most of the people, they just go and rate out of courtesy. So that can also create the biases. So that's why you need to like be, I mean, these are the kind of one of the example like how you can do it. And do you have any other example, like for example we discussed about the Google Maps? Like, how do you find these sources of bias,
Yeah, I think it's similar to the grading example from the book. It's just a lot of people use models trained on biased data or taking in biased inputs, and they just, because it's a standard practice to say, "Hey, how good is this restaurant? Let's look at the reviews." No one thinks, "Oh, that's biased," but it very much is. So I think we really need to like I think radical open-mindedness is a term I heard a while ago. Really question everything, even the things we kind of currently take for granted because it's just done normally. You really need to like think about it. Like, are these reviews biased?
Yeah.
So,
And we'll end up in a spot potentially where if you can direct traffic to businesses based on the reviews, then there's going to be a secondary market that pops up for AI generated reviews. So then you can say like, well, look at this place that, I mean, there's already AI generated reviews all over the place. And so if now Google Maps is saying, well, the LLM sees that there's a lot of really good reviews for this place, will it be effectively able to tell that those were real reviews or not? And the kind of trust systems get taken apart because of those secondary markets, because you can just kind of pay for those reviews. So a lot of interesting things on the horizon.
It turns into like a large scale GAN.
Yep.
This is something similar to, YouTube video views. People used to do, bot generated views and
Yep.
get 1 billion views or something. So and they pay. Yeah.
Yep.
So I would hand it over back to, Anirudh. Thank you.
Thanks, Atif. All right. So with the last 10 minutes, we're going to cover what irresponsible AI looks like. Unfortunately, there are so many examples out there. I'm just going to touch on a few before we jump into some more discussion questions. Evil AI cartoons is where I got this cartoon from. It has a lot of really funny examples of extrapolations of where AI could hopefully not go. But some of the unfortunate examples out there for irresponsible AI include a model by a company called Chai encouraging a Belgian man to commit suicide because of his fear around the climate crisis. They responded by making sure that the bot would respond more appropriately when someone was expressing thoughts of self-harm, but hadn't had those guardrails in before this incident happened, which was incredibly unfortunate. US company called Arity opaquely would gather data and then set car insurance rates based on the driving data that they would get from different car companies and different apps, and there would be no way to tell why you got this price, and you'd have to appeal through the Fair Credit Reporting Act, and still wasn't very transparent or fair model, at least from the eyes of the consumer. In the Netherlands, the Dutch government put in this system for anti-fraud called Siri that had run for over 12 years to determine whether, based on a bunch of personal data, someone could defraud the government. And it miscategorized people for all those 12 years and never caught a single fraud. Instead, just denied people services to the government because you ended up on a list where you were deemed untrustworthy. Chip shared a couple of incident collection databases that are depressing and useful, but it's good to be aware of those kinds of things that can go wrong, those failure modes for the systems that we build. So let's jump into discussion real quick. What do you think would disincentivize irresponsible AI? Are there any systems in place that we can be aware of? Is it awareness? Is it regulation? What do you all think?
I think increasing accountability in general, like if you produce a system or choose to use a system, like you can't just say the computer decided it. You need to say, I decided to use that computer, therefore I am held accountable. And if we could just increase, like, people treat black box as therefore you can't judge me for using it. It's like, no, you should be held accountable for choosing to use that particular black box.
So, I think it's gonna be useful to understand like where this responsibility happens. Is this from like model providers, model users, or like application developers? And I felt like model providers or developers know what is the right thing to do. They just don't do it because profit gets in the way. And unless we have a way to like control for that profit flow, it's gonna be very hard. Away from capitalism. Yeah.
Yeah, Ilya has entered the chat.
But even beyond the profit motive, there's still like the ego. Like if you work, like imagine being on that project that was catching fraud, and that's probably a team of people who spent quite a lot of time developing this system that literally didn't work. It just made everyone's lives worse. I imagine that when you're there, it's like, oh well, am I going to admit that everything I've done doesn't work just completely for nothing. Like this model doesn't work. Therefore, my entire team and our entire project just fails, and whoever's leading that team just fail. It's like that's such a giant blow that even taking profit away, where you have government jobs, like where the government is the one doing the project, like they're not. I mean, they're saving the government money, they're not making money themselves. But there's just this big like I imagine hit to the ego that they're just like, you know what, like it's probably still better than nothing, even though it's not. It's actually significantly worse. Yeah.
I think like policymakers are, our law enforcement, they can step up. They set, they set out the regulations and, laws and etc. so that you scrutinize those, individuals or organizations who practice irresponsible AI. That will be a contributor.
I think in addition to that, I was thinking, I don't know how to describe it, but you know how with the FDA, if you have a certain drug, if you have a certain, I don't know, type of medicine, like you have to go through several studies and trials to prove its efficacy, its safety, and whatnot. Be kind of nice if we could do that with AI that has a lot of reach, and that way you could demonstrate, hey, this thing is safe and it won't do bad things, or you could have different people try to poke holes through it and understand that you're missing a whole bunch of edge cases, or you're missing a whole bunch of very normal use cases, and they're just flat out being ignored. I think something like that would be also quite nice. So subjecting things to study would be interesting.
Yeah, absolutely. All right, for the sake of time, we've got about 4 minutes left. I'd encourage everyone to continue the discussion on Discord, as well as the second question on this. We have so many examples, so I'd love for people to throw in examples for responsible AI if they feel comfortable in the Discord as well. But I want to end out this discussion with responsible AI and what can we see more of? What should we see more of? Because of legal implications, probably. We don't see a lot of blog posts that are like, we didn't do this really well, so here's how we fixed it. So most of our good examples that I've found come from companies trying to responsibly tackle responsibility and accountability early in the process. So an example that I really liked is OpenAI's free moderation endpoint. This doesn't cost account towards any of your token counts. It's completely free to use and integrate into any of your apps, and it basically gives you moderation on quite a few categories, harmful categories, and so you can grade whether you want to allow inputs and outputs using this moderation endpoint. Making this freely available is definitely a good step, because then you spread it out. Whether it's always accurate is a different discussion, but I think it's the right step. Another example is Anthropic's constitutional AI, where you're not fully relying entirely on human labeled data, and instead you're relying on constitutional principles and using a combination of supervised learning and reinforcement learning to then build better AI systems. Hugging Face's adoption of model cards is a really wonderful thing to see. Most big companies do include model cards on their models now, which is probably the largest implementation of it that I've seen so far, and most widespread. It's not to say that every model on Hugging Face has a model card with like risks and evaluations and data sets used, but I think probably it's a pattern that's growing for the largest models that are in use. And from the largest companies that are putting out models. One of the last examples I'll use is TensorFlow's Know Your Data initiative. It's a service that allows you to essentially have annotations on data sets that are accessible through the TensorFlow Datasets API, and it kind of helps you understand, is my data corrupted? Is my data sensitive? Does it have gaps? Is the distribution imbalanced across various attributes? This is a really wonderful step in making sure that we're tackling those kinds of biases early in the cycle. And then I'll close out like the responsible AI examples with how a lot of API providers for LLMs are opted out by default in using your data to train, which is a nice pattern that we're seeing. So for the last set of discussions, I know we're right about time, but I'd love to hear if people have had experiences where responsible AI was promoted and expected.
I think a lot of companies are promoting responsible AI, raise money, on the premise of the responsible AI. But the questions of like, I think we talk about safety, it's a question like who decide what safety is like or what is responsible looks like, because maybe like someone, because like what we think of as safe is determined by our worldviews, and people with different worldviews and different perspective may have different definitions of what safe or good looks like.
Yeah, I completely agree. I think it's pretty hard to make policy around this stuff because it's pretty hard to agree on policy.
So, by the way, like promoting is one thing, but are they investing into it or not? Are they hiring experts or not, like privacy and security experts who also know the AI, So that's another, side of the story.
Yeah,
follow through is hard.
Yeah, the follow through. And even if you hire the experts, are you giving them power to actually do the safety and guardrailing and stopping the progress that might be a little bit risky? Yeah, this is like also not an AI related, not an AI strictly AI problem. This is something, we've got OSHA and all these other safety and security issues, and they all face the same issue.
Right. At least OSHA is an accountability mechanism, and we don't yet have something like that, right?
We need OSHA AI.
Yeah, OSHA AI. Yep, exactly. And the very last question I had, that I think we can just move to Discord is if people want to share other examples they've encountered of responsible AI. Given that we are at the top of the hour, we'll close it out. Thank you all for sticking with us over the last 11 weeks, and huge shout out to the TAs, to Chip, and to all the participants to help us make this possible.
Thank you so much, everyone. I've learned so much through all of the presentations and discussions. So for people who follow along, I think there's a discussions on Discord on whether people want to continue with another book. So you probably know by now, I think like book club can be a great way to learn, but it's also a lot of work. So I really appreciate everyone who have like put into energy to prepare presentations, answer questions. So like for another book club to happen, I think we do need one, decide on like what you read, and second, who would be the core members who would be driving the book club forward. I think I'm gonna stop the live stream now.